Welcome to another Mount Holyoke Psychology Statistics Hub tutorial. This is your lab director, Natasha, with a new research question for you. Jorge is a campus celebrity, and students love taking pictures with and of Jorge. Does the average number of pictures taken differ based on your class year? So do first years, sophomores, juniors, and seniors take different amounts of photos with Jorge on average? What analysis can you use to answer this research question? The one-way ANOVA tests means of different levels of an independent variable on a dependent variable. You should run a one-way ANOVA when you want to compare means of different levels and groups of a variable on a dependent variable. In this example, we ask, is the average amount of Jorge pictures taken each year different for students who are first year, sophomores, juniors, or seniors at Mount Holyoke? So to run a one-way ANOVA using SPSS, first we'll go up to Analyze, down to Compare Means, and over to One-Way ANOVA. In the dependent list box, we'll put our dependent variable. In this case, we're curious about the number of Jorge pics taken. And then in the factor, we'll put the independent variable, which in this case is class year. We'll want to click the Options button, and then make sure to mark Descriptive and the Homogeneity of Variance Test. Click Continue, and then OK. And then our output will come up. The first table shows us descriptives, and it tells us the number of students in each group, so 26 first years, 25 sophomores, 24 juniors, and 25 seniors. Then it gives us the means and standard deviations for each of the classes. It looks like about 9 pictures were taken for both first years and seniors, and about 4 were taken for sophomores and juniors. The next table is the test of homogeneity of variances. And just like when we ran an independent samples t-test and we were comparing means of different groups, one of the assumptions is that the different groups will have similar variances. And that is an assumption that is the same with independent samples test and also with ANOVA. So in this case, because the p-value is less than 0.05, it's actually saying that the variances between the groups were not similar. So that is actually a violation. And so we'll have to run a different type of post hoc test if we need one. So let's see if we actually do need a post hoc test. We'll look down at the ANOVA table itself. This p-value under the SIG column tells us whether the ANOVA itself is significant. And in this case, it is. It's below 0.05. So what that means is that there is a significant difference between class years and how many pictures they take of Jorge. This table also gives us our degrees of freedom and our F value. Now, just based on this table, we know that there is a difference between class years and the mean number of pictures they take. And we have maybe some sense of idea based on these numbers, but we don't know which are significantly different from each other until we run a post hoc test. So let's go back and we'll do the same, take the same steps where we'll go to Analyze, down to Compare Means, and then to One-Way ANOVA. This time we'll click the post hoc button, and because we know from the output that this test of homogeneity of variances was significant, we cannot use one of these tests like Tukey that you might be more familiar with, because equal variances are not assumed. We cannot assume equal variance, so let's use the Games-Howell test. So we'll click the Games-Howell, hit Continue, and then hit OK. All of the same output will also come up in this window now, but with the addition of this post hoc test. Everything that is starred is where the significant differences lie. Now, this table is a little confusing because things are repeated more than once. The pairs are repeated more than once. So for instance, we can see that the difference of numbers of pictures taken between first years and sophomores is a significant difference. It's marked here with a star. We can also see that it's below 0.05 in the SIG column, but that difference is repeated down here. It's the same difference. It's between the sophomores and the first years. So we can see that for each pair, it's actually written twice on this column. So that's why in this table. So that's why the post hoc tests are a little bit clunky in SPSS. But despite that, we can easily identify with these asterisks or stars where all the mean differences are. So there's a significant difference between first years and sophomores, and also between first years and juniors. The difference between first years and seniors is not significantly different. So then we can also see that the difference between sophomores and seniors is significant, and between juniors and seniors is significant. So again, you'll want to spend a little bit of time with this table, especially when there are multiple pairs that are significantly different from each other, to figure out what that means. And now that we know that these are different from each other, we can go back up to the descriptives table and look at the means. So for instance, since we know that the first years and sophomores are significantly different from each other, we can say that the first years took significantly more pictures of Jorge than the sophomores did. Similarly, we knew that the difference between first years and juniors was significantly different. So you can also say that first years took significantly more pictures than juniors did, and so on. So there's a lot of information to look at when we have the output from the one-way ANOVA, but if you spend some time with it, it's pretty easy to decipher. So remember, until next time, don't be mean, be above average.